Okay, folks, this should not be your introductory foray into the International Baccalaureate Internal Assessment for Group 5 Mathematics. I'm a big order of operations fan, as you might imagine, so I think that if you're trying to choose a topic before you understand what the IA even is and how it's graded and all that, that will be a recipe for disaster. So at this point, you should already know the basics, like the IA is a 6 to 12 page paper with a very strict word count. It's graded on 20 marks out of 6 criteria. They're the same for SL and HL, although there are slight differences between applications and interpretations and analysis and approaches. And a bunch of stuff I just said is not even true. So please go back and watch the previous videos in this series before sitting down to watch this one so that you know what's going on. Okay, I promise I'm not going to intentionally lie for the rest of this video. However, these are just my opinions, informed by my years of teaching IB mathematics, collaborating with other colleagues, whether it be in schools or online forums or at in-person IB teacher trainings. Hopefully you find some of what I discuss in this video to be of some value to you. We're going to cover a lot of ground. Let's talk about choosing a topic. One question that you might want to ask yourself right at the get-go, and I should stress, I do not believe that there is a correct answer to this question, is do you want to write about some mathematical topic that interests you, or do you want to write about just some general topic that interests you, which you've figured out a way that you can analyze mathematically? I think when you look at old IAs, it's not difficult to determine how the author would have answered this question. Sometimes you can tell just by looking at the title. And there are good and bad examples for both. And I have some notes here about the criteria. This is really just a hunch, but I think that if you write your IA about a mathematical topic primarily, then you're probably going to find it easier to score your points in Criterion E because it's pretty much guaranteed that it's a topic that is commensurate with the level of the course, probably something that you've spent a lot of time thinking about, so you can demonstrate good, if not thorough, knowledge and understanding. If you're at an HL level, you might be able to find something that's really sophisticated and rigorous here, but you run the risk of potentially having more of a challenge in Criterion C because you might not be able to really put your personal voice into the paper depending upon what directions you take it. It may feel too much like a textbook exploration or something that I could easily have found on some website. Whereas if you choose just a general topic, I think that would be flipped. You're much more likely to be personally engaged in finding the math in that topic, but you might struggle, especially at HL, to find mathematics that is sufficiently sophisticated and rigorous and that you understand and that is also related to your topic. Now, look, it really doesn't matter that much. You can write a very good IA scoring very poorly in any one of the criteria as long as your other ones are pretty good. So I don't want you to worry too much about this, but this is just something for you to think about as you're taking your first steps into choosing a topic. Speaking personally, I think that I would have an easier time writing a paper using the second route. I happen to enjoy looking at some concept in the world and figuring out how I can analyze it mathematically, and we'll have some examples of that later on in this video. If I had to choose a math topic that interests me and write a paper about it, I'd probably do something like non-Euclidean geometry. I've always found that to be very fascinating. And I know that it has some connections to astrophysics, and some models could then be related to art, maybe M.C. Escher, and I don't know, that's where I would start. But I honestly, I struggle trying to imagine where that paper would end up if I had to approach it that way, because that's just not me. But if that is you, then great. Write a paper about a math topic. I might look through a textbook or two. Some of them do have very interesting project ideas that could be modified for an IA. And I would definitely consult YouTube. This is a list of some of my favorite mathematics YouTube channels. I'll put links in the description to the video. I highly recommend checking them out. There's a wide variety of content that you'll find between and even just within a single one of these channels. Some of it is accessible to a general audience. Some of it I've actually used as a learning tool and incorporated into my HL lessons because they've taught me tricks that I never saw in a textbook or learned in college. Blew my mind. And some of the videos, honestly, I need to pause and have a long think about before I continue because my head hurts just trying to deal with the concepts that they're presenting to me. So I certainly don't mean to suggest that every video you could possibly find here is going to be a good IA topic, but there are some really great nuggets if you go searching for them. Next, I want to show you some of the content that the IB has published to help students choose a topic. Everything I'm going to show you here you can find online, or you could ask your teacher to share it with you. We're looking at the teacher support material. Yes, this is the analysis and approaches document, but we're looking at the appendices, and that's going to be identical for the applications and interpretations. We begin with a list of previous IA titles. I want you to read through this list so that you can see just how wide open this assessment is in terms of what you could possibly write it about. You're going to have to hit pause and play a few times, however, if you want to be able to read through all of these without downloading the actual document. These papers weren't necessarily all good, but that doesn't mean that the topics themselves were not good. And if something really jumps out at you, then I encourage you to consider using that as your topic. And as you read through these, think back to my opening question. Whether the author started off thinking about math, a hobby, or perhaps found a balance between the two, there are many ways to approach writing the IA. If that was a little too much, then we can zoom out a little bit and take a look at this list of stimuli from the teacher support material. None of these is fully fleshed out into a full IA topic or title just yet, but any one of these could serve as your first step in deciding what you want to do. And one thing you can do with a stimulus is make a mind map. And this is an idea that I had never heard of before teaching IB. So let's take a look at their official mind map for the stimulus of water. So a mind map is just a web centered at or beginning with your initial stimulus. So you would start off just by writing that one single word or idea on paper and then just start brainstorming from there. So we've got questions here about how many people can survive on the amount of potable water that we have on Earth. So we need to figure out a way to estimate how much water there even is on Earth. We could talk about storm surges. We've got tsunamis, floods. How big can a wave be? Sailing. Effect of wind and water currents, size and the geometry of sails, weight and material of the boat, rainfall. We've got drizzle versus torrential rain. We can model the rain droplets, do a statistical study. We could collect rain and do something with that. We could talk about modeling water jets or looking at the geometry of water fountains. We could talk about the effect of salt-saturated water on polar ice caps. So we'd have to talk about the differences between sea ice and snow ice, the permeability of sea ice, and how does ice grow and melt. Now this is like the classic mind map. If you do a web search for IB Math mind map, you're going to find the water one all over the place. I couldn't actually find a ton that I loved from outside of the teacher support material. So I thought I might make some of my own. This is actually the mind map that I used to plan out what to say in this video. It got a little meta. I came up with a few topics, and then I tried to mind map them as though I was writing my own IA, and I think I was successful. At one of them, I only did this one. Let's go on a spike ball adventure together, children. Oh, good Gauss in heaven, I love this game. Yeah, nothing to see here but me making a sweet dive. I love that picture so much it's my Facebook cover photo. I love that picture so much I commissioned a painting of it. I'm sorry, I'm getting distracted. Let's all stay focused on Spikeball. I mean, this mind map of Spikeball. And of course, if you're not familiar with the game, then most of this example is going to be useless to you. So you should go out and learn about Spikeball. It's an amazing game. But anyway, I actually made this mind map over a year ago, so I've actually forgotten what some of the notes in it even mean, but let's just go through it together. Started here in the middle with spike ball, and then I was thinking about the angle of spike. You see, if you spike straight downwards towards the net, the ball ends up popping up really high and landing nearby. Real amateur move there. No. You want to get low, send that ball flying far away. And then I was looking at these pictures I drew and said, well, what kind of a function is that? Well, that's going to be the absolute value of a quadratic that's opening downwards. So then I thought I could film some spikes, maybe overlay a coordinate grid over the footage. I realized I could get Logger Pro involved. If you're not familiar with that, that's a great piece of software for collecting and analyzing data, usually in like a physics context where there's objects in motion. So if you've got an idea that might come to life with something like that, definitely talk to your math or physics teacher about it. And then thinking of film, I realized that I could compare footage of amateurs versus professionals. I mean, I don't know if these people get paid, but there are big names in the spike ball community. I could get that footage from ESPN2. They've got a great Instagram. I work at a school, so I could get my amateur footage from the campus. And then I thought, well, what could I be analyzing here? Well, you could work out the distance that various players run. You could work out the distance that their spikes travel, the serve velocity, how often they use their, I wrote left hand here, but really just their weak hand. The distribution of passes, since you can use 0, 1, or 2 passes in any play. How often do pros pass versus amateurs? And now for something completely different, I started thinking about physics, because there can be a lot of variation in terms of how much the ball is inflated. So I was wondering, would that have an impact on distance or accuracy of a spike? Of course, there's a lot of other things I'd have to consider here, like if you're playing outdoors, is there wind? You've got friction and air resistance. Some of the energy of your strike is going to be absorbed by the ball itself. There's different types of balls. You've got a pro ball versus a regular ball. To measure distance in a controlled environment, I realized since you're not going to be able to control how hard you spike the ball, if I took various balls up to a high point and then dropped them, I could measure how high they bounced after they hit the ground. And then the force of dropping the ball onto the ground would take the place of the controlled spiking velocity. Then I thought, oh, if the ball continues to bounce a whole bunch of times, that's going to give me a nice converging infinite geometric series. You've probably seen problems like that before. I also started thinking something about statistics and regression, although I'm not really sure what that was. And somehow that tied together with this that I can't even read. It says ACC. Is that accuracy? Is that acceleration? I don't know, and there was even a question mark on my page, and it says drop arrow, measure distance of bounce from initial spot. I think that meant if the ball dropped, would it bounce straight up or would it bounce off to the side? Although I don't know why that would have been interesting at all. So anyway, that's my spike ball mind map, and I just threw this together in a couple of minutes. If I were doing this for real, I'd obviously spend a lot more time on it. I would also get some friends involved. I would look at their mind maps, they would look at mine, and we'd brainstorm together. Right, so what about this other stuff? Euler curves. Okay, this is a phrase that I made up. I think it'll make sense in just a minute. This idea was born out of me just wanting to do something kind for my now wife. A few years back, she woke up much earlier than I did in the morning. She wanted to enjoy a hot beverage, but we lived in an apartment that took like 5 minutes at least to get any hot water out of the kitchen sink, and we also owned a very cheap water boiler. So it took forever to boil water in the morning. So my idea, being a man of science, was to pre-boil the water. I went to bed later than she did, so I would boil the water before I went to sleep, and it would hopefully be a few degrees warmer in the morning than if it had just been left standing. She was reasonably skeptical. So my plan was to get some high quality thermometers, thermal readers, what have you, from the physics lab at my school, and then do some temperature readings, find out if the temperature of the water actually was warmer in the morning. But rather than just take the temperature in the morning and call it a day from there, I thought that I could calculate how fast it would take the water to decrease to room temperature. I thought about Newton's law of cooling. We could get some calculus going on there. I could then predict what the earliest time at night was that I would have to boil the water for it to have an impact in the morning, and then I could test that prediction. Another important consideration is how long does it take the water to boil depending upon its starting temperature. For example, say it takes 5 seconds for the water to go from 99 degrees Celsius to 100 degrees Celsius. Does that mean that it will take twice as long, 10 seconds,
to go from 98 degrees Celsius to 100 degrees Celsius? I don't know. There's no reason to suspect that it must be a linear process. This is kind of where the title came from. I was imagining drawing a bunch of curves of water cooling down and heating up depending upon things like, its starting temperature, the ambient room temperature, both at night when the water was pre-boiled as well as in the morning when it was uh, post-boiled, whatever you want to call it. Also, the material composition of the kettle would be an important thing to think about. Now, look, I don't actually believe that pre-boiling the water had any meaningful impact. Everybody I've spoken to has said that I'm crazy. Some casual web searching suggests that I had no impact on my wife's morning beverage. I'm not giving this as an example because I think that boiler curves were such a great idea, truly ahead of their time, but I want this to serve as a model for how you can take a simple, mundane topic and approach it mathematically. And you think about all the stuff I was just talking about. Clearly, I'm personally engaged in this one, so I've got that criterion checked off. I think I've got plenty of reflection. I've got some calculus there, so my use of mathematics is going to be all right. As long as my presentation and communication is good, I've got a solid paper written. And it's that process that I want you to take away from this so that you can apply it to something that interests you. Okay, I've got one more example now. I have a bit of a love-hate relationship with fantasy football. It's fun, and while there is knowledge and skill which goes into being successful at it, there's also a lot of randomness, in particular in a head-to-head league. And over the years, I have set out to study this randomness in increasingly complicated spreadsheets. You can track how well teams are doing from week to week. You can work out how they rank within a given week out of how many teams are in your league. You can calculate the average points per game scored, the points per game standard deviation, the points per game z-score, what their average rank is out of the league, what the rank of their rank is, the standard deviation of their rank, a rolling average of how many points they're scoring over the last couple of games. You can compare actual wins to expected wins, calculated both on offense based on their rank, as well as expected wins based on defense, which you can calculate by working out the strengths of their schedule depending on how strong their opponents were when they played them. There's so much you can do because your score is essentially independent from the scores of your opponents and everybody else in the league in any given week. My favorite had to be in 2018. Look at the strength of schedule z-scores. This guy had a z-score of nearly 3. Higher numbers meaning easier teams he'd played against. That is preposterous. Compare that to the rest of the z-scores in this column. It's absurd. Look at the ranks of the teams that he played against. This was in a 12-team league. In week 1, his opponent placed 9th out of 12. Week 2, 10th out of 12, 11, 7, 9, 10. He never played anybody who in that given week performed in the top half of the league. He went undefeated for the regular season, 13-0 compared to his expected wins of 7.8. Meanwhile, this other character, known as Me, was tied for the third most difficult strength of schedule. I ended up winning 7 games in the regular season with an expected win of 8.8. These expected wins based on offense, by the way, not strength of schedule. I was not calculating expected wins based on defense in this particular season. Anyway, I managed to squeak into the playoffs and was eventually named the champion because I had a strong team. I had just been unlucky during the regular season, whereas this person was extremely lucky during the regular season, but objectively had a worse team than I did. But I do have to show some respect. They did have the 4th best offense in the league that season. I only had the 3rd, so one could argue that I was a little bit lucky in the playoffs as well. But I mean, this guy, the whole year, just talking trash to everyone about his undefeated season. One and done in the playoffs. One and done. Get out of here. Oh, and this is cool. You can take all the scores put up by every team over the course of the entire season and make a histogram, and then check this out. It's going to approximate a normal curve. It's pretty neat. Now, again, I don't know that this would be a great IA. In particular, I'm a little skeptical of how well I would be able to demonstrate my knowledge and understanding of the mathematics that I'm doing in the spreadsheet. But this is just to show you how you can approach a topic. I'm clearly personally engaged in this. I've obviously reflected a lot over the years as I've added things into my model, and you should be able to find something that you're interested in that you can approach with a similar level of enthusiasm. And that's your next step. You've got to choose your IA topic. If you're near the end of your first year or the beginning of your second, the time is now. So get out there, read some more old samples for inspiration, talk to your friends, talk to your teacher. You don't need to come up with anything groundbreaking or unique, but you definitely don't want to wait until the last second because then you'll end up making an impulse decision and settling on something that's not really that good. Getting over this initial hurdle can be one of the most challenging parts of this entire process for many students. It can be really overwhelming because it really is wide open as to what you can choose. But I think if you just follow your heart, choose something that you're interested in, and don't overdo it with something that's needlessly complicated, you're going to be just fine. I wish you the best of luck.